Hey everybody, we are going to do our section 9.3. Today we're talking about hyperbolas. So I want you to kind of think about this. Parabolas have that bola at the end, and hyperbola is kind of like when something is extra or like, more than normal. So a hyperbola is kind of this idea of two parabolas that go opposite of each other. So this is called a vertical hyperbola, and this is a horizontal hyperbola. Okay, so the branches are two disconnected parts of the hyperbola. So again, they're disconnected, they're not connected to each other. And the transverse axis is the line segment connecting the vertices of the hyperbola. It's also the value of 2 times a, which we'll get into that. And the conjugate axis is the line segment in the hyperbola of length 2b. Okay, so we'll talk about what that looks like in just a second. So in a hyperbola, again, if it's vertical, it will look like this and this, where the inside are the two foci. Okay, and if it's horizontal, it will look like this and this, where the insides are the foci. Okay, so the line through a hyperbola is two foci, so that's these, either these two vertically or these two horizontally. And where it intersects the hyperbola, those points are called the vertices. So that would be where, like, if I were to connect these two points are those vertices. If I were to connect these two points on the hyperbola are called the vertices. Okay? And the midpoint of the transverse axis, that's that green line that I just drew, is called the center. So the midpoint would be like right here, and the midpoint would be like right here. That's the center, okay? So that's the center here, or the center would look like that. And the standard form of the equation of a horizontal transverse axis means that it's also a horizontal parabola, and that's going to look like x minus h squared all over a squared minus y minus k squared all over b squared equals 1. And the standard form of a vertical transverse axis is when it looks like this. And that's going to be y minus k. I'm going to erase that real quick. Y minus k squared all over a squared minus y x minus h squared all over b squared equals 1. You probably are thinking to yourself, this looks really familiar. Keep in mind the difference between a hyperbola and a parabola as far as their formulas go are not a whole lot different. The main differences that you're going to look for is that there's a negative in the middle instead of a plus. So think about those two pieces to an ellipse come together. We're adding them together. And a subtraction is we're taking them away. We're pushing them apart. Okay? All right. So, and then also, in each case, the vertices or foci are c units away. So this is similar with an ellipse where the foci are c units away. But the difference is that the formula, instead of c squared being a squared minus, like the ellipse, this is c squared equals a squared plus b squared. Okay, so ellipses are minus, but the hyperbolas are plus. And then if the center is at 0, 0, and it's horizontal, we say that's x squared over a squared minus y squared over b squared equals 1. Or if it's vertical, we say that's y squared all over a squared minus x squared all over b squared equals 1. Okay, so now the thing that's going to be super different from an ellipse is we have to calculate something called asymptotes of a hyperbola. And the asymptotes of the hyperbola are going to look like this. And let me show you what that looks like right now. So the asymptotes of a hyperbola with the horizontal transverse axis, remember again, that's the horizontal parabola, is that y equals, and there's two asymptotes, so it's k, the value of k plus or minus the value of b divided by a times x minus h. And the asymptotes of a hyperbola with a vertical transverse axis look like y equals k plus or minus a over b times x minus h. So the subtle difference is right here, whether it's a over b or b over a, okay? And asymptotes that pass through the corners of those rectangle dimensions of 2 times a by 2 times b. So this is a rectangle of dimensions. We're going to talk about what that means in just a second. And the center is at h, comma, k. So I'm going to show you what all of that means coming together right now. So this example says, sketch the graph y squared minus 9x squared equals 9. So remember that in our general form of our hyperbolas, we're either x minus h squared all over a squared minus y minus k squared all over b squared equals 1. Or, and that was our horizontal, or they were y minus k squared all over a squared minus x minus h squared all over b squared equals 1. And that was for a vertical. Well, looking at this one, and now the difference here is for hyperbolas, it's not a is always bigger. It's whatever variable comes first tells me the direction of the shape. So since this y is positive and it comes first, that tells me it's going to be a vertical one because of this y right here, okay? So we're going to try to make it look like that general form. So remember, this right here equals 1. Okay, whoops. This right here equals 1, so I need this to equal 1 as well. So we're going to divide it by 9 on everything. So we get 9 divided by 9 equals 1. Here, if I simplify this, 9x squared over 9 is just x squared over 1. And y squared over 9 is going to be right here. So if I'm comparing this now to that general form right here, and I'm looking and trying to break it down, our h comma k is going to be 0, 0. Our a squared, oops, is going to be right here. So then a is the root of 9, which is 3. And our b squared is right here. So our b is a positive 1. So let me show you what we need to do with that, okay? So our h comma k is 0, 0. We're going to graph that right there. Our a, in this case, now remember, a does not necessarily have to be bigger, but in this case it is. It's also under the y-axis. So we're going to go in the vertical direction is going to be 3. So vertically, the direction of a is 3. So we're going to go up 1, 2, 3. So this is a, and we're going to go down 1, 2, 3. That's kind of similar. For our b direction, it is going to be horizontal. So we're going to go over 1, and to the left 1. Now, instead of drawing an ellipse like we did before, we're going to take this and we're going to make our rectangle. So we're going to write a rectangle of dimensions 2a and 2b. So we kind of go across this way, and we're going to go through it this way, and we're going to make a rectangle that meets up like this. Okay, so here's what we're going to do with that rectangle. See those corners? This corner to this corner is going to be our first asymptote, and it goes through that center there. See the center? See how it went from corner to corner through the center, and that's my first asymptote. And then my second asymptote is also going to go from corner to corner and go through that center as well. Those are my 2 asymptotes. Remember again, corner and corner, go through the center, 2 asymptotes. Now, we're going to graph our vertices of our hyperbola, which we know it's vertical, so we're going to go in the vertical direction. This is my vertice. This is my other vertice, and from here, I'm going to graph that parabola on the bottom, but it's going to follow the shape of those asymptotes as a guide. Same thing with this one, asymptotes as a guide. So really, the green box it's invisible. We don't actually see it. We had to graph it to show the shape of the hyperbola. And the asymptotes, we don't actually see it, but the purple on the hyperbola is actually what we're talking about. We're not going to talk about the eccentricity today or the applications, okay? The next part, if the graph of some standard form of a conic section looks like this, here's the thing. The only one that we care about is really the A, which is the coefficient on the x squared, and this C, which is the coefficient on the y squared. So it's a circle if the A value is equal to the C. It's a parabola if A times C equals 0. It's an ellipse if A times C is a positive number or greater than 0. And it's a hyperbola if A times C is less than 0 or negative. So if it says classify 9x squared plus y squared minus 18 minus 4y plus 4. So all you're going to do is look at A and C. So our A is 9, and there's nothing in front, so it's actually a 1 is C. So if A is 9 and C is 1, we're going to compare, well, is A equal to C? No, they're not equal. So we're going to find the product of A times C, and what do we get? So we get A times C is 9 times 1, which is 9, and that is this. It's greater than 0, so therefore it's an ellipse. Once we know what it's supposed to be, then we can make it look like the equation of an ellipse, but we'll do that later. Okay, that's it for today. Thanks, guys.